All right, today we're diving into an AI project that has seriously a killer name and an even cooler mission. It's called Reservoir Pies. And you can kind of think of it like this crew of AI agents, right? Each one has a very specific job, and they all have to work together to make sure things run smoothly, especially when things get, well, tough. And this quote, this is from the project's own documentation. It just hits the nail on the head. It says a lot of agent projects become hard to operate because everything is mixed together. And that's so true, right? When you have a bunch of AIs all trying to work on the same problem, it can just descend into total chaos. And look, that chaos, it isn't just messy. It can be really dangerous. I mean, just picture it. You've got all the different parts of an AI, the part that listens, the part that thinks, the part that actually does things, all just thrown into one big digital soup. That is a recipe for disaster. It makes the whole system unpredictable, a nightmare to fix, and honestly, impossible to trust.
So that's exactly where this project, Reservoir Pies, comes in. It is a genuine attempt to bring some order to all that potential chaos. It's all about building an AI system that's based on structure, on rules, and on a really clear separation of jobs.
Okay, so what is Reservoir Pies exactly? The best way to think about it is like an AI workplace. You've got this team of AI specialists, and each one has its own little desk in this, virtual office. But here's the cool part. This office is spread across a bunch of those little Raspberry Pi computers. They're all networked together to talk to each other, clearly and reliably, which is super important when you're dealing with something like a spotty radio-linked system. And the core idea here is it's just brilliantly simple. Separate the jobs. You have one part of the system, they call it the edge, that just handles all the messages coming in and going out. Then you have another, much more powerful part, control, that does all the heavy lifting, all the deep thinking. And connecting them? A super strict set of rules to make sure they're talking to each other clearly and safely. That's it. That separation is the magic sauce that makes the whole thing stable and, understandable. Okay, and this is where it gets really fun. The project actually borrows its whole naming scheme from the movie Reservoir Dogs. It's such a clever way to give each AI agent its own personality and a super clear job description. So yeah, let's meet the crew. All right, so first up, you've got Joe Cabot. He's the boss. He's the authority running on the beefier hardware back in the quote-unquote office. Joe's the one making the big policy calls and handling the really complex stuff. Then you've got Mr. Pink. He's working the front desk, basically. He's out there on the edge, right where the messages are coming in. His job is intake. He applies the basic rules, keeps things moving. He's the gatekeeper. So that's the crew, but how does it all actually work? Let's trace the path of just one single request as it flows through the whole system, because this is where you really see the genius of this setup. Okay, so a message comes in from, let's say, a radio channel. Mr. Pink, our guy on the front lines, grabs it. First thing he does is check it against security policies. If it's a simple request, he can handle it right there. But if it's something more complex, he escalates it. He forwards it on up to the boss, Joe Cabot. Joe then analyzes the request, does the deep thinking, and generates a really structured result. Then he sends that answer back down to Mr. Pink, who delivers the final formatted reply to the user. See, it's a clean, step-by-step process, a well-oiled machine. Now, this whole operation is built on something they call the hard rules. And these are exactly what they sound like. They are the non-negotiable principles that keep this whole AI crew in line. They make sure every single action is safe, reliable, and secure. Which leads to the big question, right? For any AI system that's going to interact with the real world, how do you keep it in line? How do you make absolutely sure that it does what you want it to do, and, more importantly, only what you want it to do? And here's the project's core security philosophy, and it's brilliant. It's this: authorization is based on a stable identity, not on some fragile technical detail. So what does that mean? It means they don't care where a message came from, like which radio channel, because that stuff is easy to fake. What they care about is who sent it. It's all about verifying the sender's identity, maybe with something like a digital signature. It's who is talking, not where they're talking from. That's the key. And this isn't just some nice idea. It's actually enforced by a set of what they call safety gates. So you've got the action gate, which means the AI will only execute a command if it comes through a specific secure channel. Then there's the sender gate, which is another layer. It says the command also has to come from a pre-approved sender on an allow list. So the AI can listen to everything to stay aware, but it can only act on commands that get through both of those gates. And the whole thing is wrapped in a secure private network using tailscale, which makes it incredibly hard for anyone to impersonate the agents. And here's a perfect simple example of these hard rules in action. The system has a really strict budget for how much it can talk back. It is literally not allowed to send a response that's longer than 5 of these little RF chunks. It's a hard limit. And that simple rule prevents it from just flooding a slow radio network with a giant rambling answer. It forces the AI to be concise and get right to the point. Okay, so why does any of this matter? Why go to all this trouble to create a system that's so structured, so disciplined? Well, it's because this is about something way bigger than just one cool project.
There's this quote from the creator that just says it all, really. The goal isn't just to make a bot reply. The real goal is to build an agent system that is, and this is key, understandable, debuggable, and safe enough to hand off to other humans or even other agents. It's not about making just another chatbot. It's about building a reliable tool that people can actually understand and fix when it breaks.
And that right there is the key takeaway. Reservoir Pies isn't just a project. It's a blueprint. It's a model for how we can build AI agents that are not only powerful, but also predictable, manageable, and most importantly, trustworthy. You could call it an architecture of responsibility, one that's designed to actually work in the real world.
So this whole project kind of leaves us with a really critical question, doesn't it? As AI becomes more and more woven into the fabric of our world, who gets to write its rules? Who is it that decides what's safe, what's trustworthy, and what should be completely off limits? That's the conversation we really all need to be having.